Exercise 4.2, question number 6. Find the domain of f of x and g of x. Right? Now we'll find f of x first, the subdivision 1. Now you see in the subdivision 1 we have two functions, sine inverse function and cos inverse function. Right? Now we know that domain of sine inverse of x is closed interval of -1, 1. Right? The same way domain of cos inverse of x is also -1, 1. So we can write that x is greater than or equal to -1 or less than or equal to 1. Similarly here also. Now what I am going to do is, in the place of x, here I am going to substitute this sine function value, and here also in the cos I have to substitute this cos function value in the place of this x value. Okay, now it is substituted. Okay, now you see here I want to find the value of x, so I have to remove this 3. To remove this 3 I have to multiply this inequality by 3. So multiplying by 3, it means -1 into 3 is -3. Here the 3 will be cancelled, and here 1 into 3 is 3. Now I have to take this -2, so I have to add +2. Okay, I have to add 2 throughout this inequality. So -3 plus 2, and here if I add +2 it becomes 0, so I didn't write it. So 3 plus 2 is written. So -3 plus 2 is -1, 3 plus 2 is 5. Now we know that modulus of any number is always positive, but here it is given -1. So this is a contradiction. So what I'm going to do is, I'm going to leave this left side inequality and I'm going to write only the right hand side inequality, that is modulus of x is less than or equal to 5, and I'm going to take this as equation 1. Now coming to this side, here also I have 4 in the denominator, so to remove that I am going to multiply this inequality by 4. So 1 into 4 is -1 into 4 is -4. This 4 will be removed, and here 1 into 4 is 4. Now I have to take this 1, I have to remove this 1 or to eliminate this 1, so I'm going to subtract 1 throughout this inequality. So -4 -1, so -1 and +1, here 0, so I didn't write it here. Then 4 minus 1, so -4 minus 1 is -5, and 4 minus 1 is 3. Now you see here there is a minus here, I have to remove this, so I'm going to multiply by a minus throughout this inequality. So we know that when we multiply by an inequality with a negative number, or if there is a sign change, so what will happen, inequality will also be changed. So less than becomes greater than, see sign change, minus becomes plus, and here plus becomes minus. So inequality also changes. Less than or equal to becomes greater than or equal to, and here less than or becomes greater than or equal to. Now modulus of x is greater than or equal to -3, so that's what I written. Modulus of x is greater than or equal to -3, and modulus of x is less than or equal to 5. So modulus of x is less than or equal to 5. Right. Now here also there is a negative number. We know that an absolute value, the modulus value will always be positive. So I am going to leave this left hand side inequality and I am going to write only the right hand side inequality. So modulus of x is less than or equal to 5, and this is taken as equation 2. Now just compare equation 1 and 2. Equation 1 and 2 are same. So from 1 and 2 we can take that modulus of x is less than or equal to 5. Now I'm going to remove this modulus. So removing modulus is nothing but plus or minus, isn't it? So plus or minus is x is less than or equal to 5. So I'm getting two sets of value. Plus x is less than or equal to 5, or minus x is less than or equal to 5. So plus x is less than or equal to 5 is taken as one part, and here I'm going to take this minus to the right hand side. So automatically inequality changes. So less than becomes greater than or equal to. So two sets of value. So x is greater than or equal to -5, x is less than or equal to 5. So equal to, so it means closed interval, and greater value, sorry, lesser value is minus 5 and greater value is 5. So x belongs to the closed interval of minus 5 comma 5. Now coming to subdivision 2, g of x is equal to sine inverse of x plus cos inverse of x. You know that sine inverse of x and cos inverse of x domain value is closed interval of minus 1 comma 1. So I can directly say that x belongs to minus 1 comma 1, because here no value is given, simply x is given. So we can directly write that x belongs to the closed interval of minus 1 comma 1. That's all. Thank you.